My microprocessor that I designed for my final project in Fundamentals of Digital Systems. So I just want to step through kind of each part of it one by one. We'll start over here in the top left with the binary counter. Um, this I just grabbed from over here in Logisim. They have a few different components that you're able to use to build the different parts, just kind of a little bit faster. Like you can grab gates and stuff. And the binary counters, the binary counter and the mux are the things I grabbed from there. But going into the binary counter, it runs off the clock, which I have going in and directly to the binary counter. I use tunnels for most of the other wiring just because I think it makes it a little bit easier to read, but this one's just connected directly. Um, and that feeds into the input for the read-only memory. Now this machine code I programmed myself. I could have used an emulator to do it, but I wanted to go through it just because I don't know. It helped me understand a little bit better what I was doing and what I was working with and looking at. So I entered all this by hand, and then that's the end of it. And then this opcode comes out and goes into the read-only memory for the decoder. So each of these different locations on it are hex for a different command. So like starting from the first position 0 to 7, we have um, the NOP, the no process, the load, remove, display, XOR, and or add and subtractor, adder and subtractor. And so those are kind of the functions of this whole microprocessor. But anyhow, so the different codes I'll take this off of reset so we can actually step through a couple times. So taking that off of there, we can step through each part of what it's looking at. And all these different probes help me to debug and see, okay, this is what number is there, this is what number is here. To have, oh, there's a 44 going into here. That's writing out this on the display. Anyhow, into the middle of it though, we have the adder, add A, add D for the different inputs over here in the arithmetic logic unit. But let's jump into the register first. So in the register is kind of where we're storing that data. We're putting, like going back over here to the load function, we're loading into register 1 in hex E, and then we're loading into register 0 in hex 6, and then we're displaying registers 0 and 1. And so going into here, let's see what we're actually talking about with that. So we have our 4-bit registers, the decode this, and then going through the decoder. Where are we looking at? Where are we at on the counter? And here's our 4-bit register coming into here. And we just have kind of a normal flip-flop coming with our data in, data out to store in whether we're writing and the clock is ticking through each step, and if our write enable is on, then it will filter through. Then jumping back out to the AL or in the register, let's go back to main. Come on, there we go. Okay, so that's the inside of the registers, and then obviously all these are just connected by bus to adder A and adder B. And that's important so that we just kind of see what we want with those to compress the many different data ins to fewer data outs. And then the register goes, we have the data out, which is one of the things that feeds into the mux to help us decide what we're doing with the data in. And then, or they just go straight into ALU, and we have a subtract, or the AFS to just select what we're doing. Going into the ALU, we have XOR, AND, OR, and ADD. And all these are pretty standard. They're just ORing everything together. What I did make it to change to was the add 4-bit, so that it didn't only work with the full adders, but it also had a subtractor function with the XORs and the subtract input. And we can just go all the way into it. And so obviously there's just a basic adder with the XOR and the ANDs going for our carryout or our sum. Coming back through, that's the register take care of in the arithmetic logic unit. And so let's just step through the program. Let's quick. Clock is enabled, but I'm going to turn up the frequency so we just can look at what's going on. And so I set it up for all the different commands in this opcode to go through and display my name and my favorite number, and to do the math of 5 plus 3 equals 8, and then 5 minus 3 equals 2, but then also 5 minus 3 equals 2. But instead of using the subtractor function, we are using the 2's complement to flip it and then add that together. And then to just show everything worked, I also did the move function. The move and the copy it over. But that is my microprocessor for fundamentals of digital systems.